In this video, we're going to see how the name of a function affects its gas cost. This might seem rather counterintuitive, but once you see the explanation, it actually makes a lot of sense. Let's create a function called green that doesn't do anything except return the value 1. Okay, at this point I'm pretty sure you know the drill. We see that the gas cost is 21,210. Now, let's add another function that we are going to call blue. But I'm going to call the function green instead of blue. When we looked at the gas costs, interestingly, they go up, despite not touching the function green. So over here, green now costs 21,232 gas. Let's add yet another function. What will happen to the green function now? When we test the green again, we see that the gas cost has increased again to 21,254. Now, here's something interesting. What will the gas cost be of blue? Blue cost 21,232 gas, just like green costed on its second try when red was not written yet. What will red cost? Red cost 21,210 gas, just like green did before all of the other functions were added. Well, if we look at what the compiler output is producing, the first thing we need to take note of is the function hashes. Blue is ed1, green is f2f, and red is 293. When we look at the actual opcodes, what happens is Solidity needs to check which function selector was included in the transaction.data. So first it checks, was red picked? And if so, it's going to jump to execute red. And then it's going to check, was blue picked? And if so, it's going to execute the code for blue. And lastly, it's going to check, was green picked? And then it's going to jump to the code for green if that's the case. Again, these came from over here. Red was 29 something, green was F2, and blue was ED. The compiler will always sort these checks in hexadecimal order. So 2 is smaller than E, and E is smaller than F. There are two takeaways from this. One is, if you have a function that is very gas sensitive, you should try to make sure that its function selector is near the top. And remember, the function selector is the first 4 bytes of the Ketchak 256 of the function name, when that function is formatted according to the specification. We talked about this in an earlier video. The other implication is that if you are benchmarking a function to optimize its gas cost, you have to not change the name, because you don't know that the changes are the result of the name of the function and thus its function selector, or if it's because of the changes you made inside of the function. If you do the math, you're going to see that each of these increases are worth 22 gas apiece. This isn't a coincidence. When we look at the opcodes over here, between each check, we see that the instructions equal, push, jump if, dupe are happening. So I guess to include everything, each sequence is a push, an equality check, a push, a conditional jump, and a duplicate, and then it moves on to the next function. A push will cost 3 gas, an equality check costs 3 gas, a push costs 3 gas, a conditional jump costs 10 gas. Oh, and a dupe 1 costs 3 gas over here. So this is 3, plus 3 is 6, plus 3 is 9, plus 10 is 19, plus 3 is 22. So for each unit down the function is, that adds another 22 gas.